Welcome back, everybody. This is going to be my final of two parts in my lecture series on probability. If you haven't watched the first video, please go and watch it now, as you're going to need that information for this one. Because here, we're going to talk about mutually exclusive events. Let's get started. Two events are mutually exclusive if the probability of one of them happening has nothing to do with the other. Or, in other words, the probability of A or B happening is equal to the probability of A happening plus the probability of B happening. For example, what are the odds of pulling two cards and getting a king and a queen from a standard deck of cards? Well, it's not possible for one card to be both a king and a queen. So what do? The probability of king or queen is just the probability of getting a king plus the probability of getting a queen. Well, there are four of each face in a deck of cards. So the probability of getting a king is going to be, there are four kings in the deck of 52 cards. And then the same for the queen. There are four queens in a deck of 52 cards. In other words, there are 8 cards that are a king or a queen in a deck of 52. But it's a little bit more interesting to look at things that are not mutually exclusive. Because if A and B are not mutually exclusive, meaning that they can happen at the same time, the probability of one or the other happening is the sum of their individual probabilities minus the probability of them both happening at the same time. And I'd like to draw a quick diagram here to show you why. So if I can think about my sample space as a Venn diagram, where everything in the universe and on the page is S. Here's A and here's B. The probability of A or B happening is the whole Venn diagram. Right? This is the probability of A or B happening. But I can't simply count A and then count B, because notice I've counted the middle section twice by doing that. So to make up for it, I remove one of those copies, and that is the probability that A and B happen at the same time. In the case that A and B are mutually exclusive, there would be no overlapping region to subtract or to double count in the first place. So here's an example. What are the chances of rolling either an even number or a number that's greater than 8 on a fair 20-sided die? Well, the probability of greater than 8 or even is going to be, just like in my Venn diagram, I count up the probability of greater than 8 and the probability of it being even, but I've accidentally double counted that middle region by doing it. So I have to subtract one copy of that it's greater than 8 and even. Now, let's look at our sample space. Our sample space is just 1 through 20. So the probability that my number is greater than 8 is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, or 12 numbers out of 20 numbers, plus the probability that it is even is going to be a 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, or 10 out of 20. And the probability that it's both greater than 8 and even are going to be 10, 12, 14, 16, 18, 20, or 6 of the results out of 20. So altogether then, I get 12 plus 10 minus 6 out of 20. That's going to be 16 out of 20. In this video, we saw how to find probabilities of mutually exclusive and not mutually exclusive events. That's going to wrap it up for this lecture series. I'll catch y'all in the next one.